Okay, Chapter 3, Section E, page 92. Change the equation below so that the exponent is unknown. Make it into a variable. So we're going to take the 3 and we're going to make that into a variable. So we're going to put 4 to the x equals 64. Name 4 methods to solve the resulting equation. Okay, so here there's, let's see if we can think of 4. One would be graphing it. If we could graph this, if we graph 4 to the x, then we could figure out when it's equal to 64, and then we could figure out x. That would be one, so graphing. And then there would also be, I'm sure you've used logarithms before. Logarithms are a way of taking unknown and the exponent like this and solving for it. So that would be another way, logs. Let's see, what else? If we can find a lot of times in math classes, the solutions to x are going to be whole numbers. So if we just try different whole numbers for x, then eventually we're going to get the right one. And that's probably what we're going to do a lot of the times. So we could call that, I don't know, we'll call it guessing for now. Okay, and you can only do that when it's a whole number, right? And last of all, we could do it with the calculator, which is probably another method that we would normally use a lot. Okay, so those are the 4 methods that, that the book refers to. If we have 2 exponent expressions equal to each other and the blank are the same, we can equate the exponents. Okay, so if I have 4 to the x, and I'm trying to figure out when is it 64, then, and if I figure out that, let's see, if 4 to the third is 64, then what I can do is say, hey, what I could do is I could just say, hey, this is equal to 4 to the third. If the bases are the same, 4 and 4, that means x is 3. Okay, so this is like the guessing method, right? So let's go through that one more time. So you got 4 to the x, and it's equal to 64. So how do you figure out that 64? Well, you do 4 to the first is 4, 4 to the second is 16, 4 to the third equals 64, and you say, wow, I found an exponent that makes it equal to 64, so I'm going to put that here, 4 to the third, okay? And then, hey, if the bases are the same, then that means x is equal to 3, okay? So if the bases are the same, then we can equate the exponents. All right, now let's move on to some problems. We'll just do the ones here on the edge. So 7 to the x equals 1. Now remember that whenever you have a number to the 0th power, that is equal to 1. So 7 to the 0 equals 1, right? So x is equal to 0. Let's see, 4 to the x plus 1 equals 64. Let's see. 4 to the third is equal to 64, like we just saw above. So if 4 to the x plus 1 equals 64, then that means 4 to the x plus 1 equals 4 to the third. That means that x plus 1 equals 3. So we'll put x plus 1 equals 3, and that means that x equals, and we subtract 1 from both sides, that gives us x equals 2. Okay. What about this one? 5 to the 1 minus 2x is equal to 1/5. Well, 1/5 is equal to, is it 5 to the negative 1, right? Because it's negative exponent makes it invert, so so that would be 5 to the 1 minus 2x equals 5 to the negative 1, so that means that this exponent is equal to this exponent, so 1 minus 2x is equal to negative 1, which means that, let's see, we subtract 1 from both sides, we get negative 2x equals negative 2, and we just divide both sides by -2, and that gives us x equals 1. Okay, let's move on down here. 25th to the x is equal to 1/5. So if I have, let's see, 25, we need to put that in terms of a base of 5, so we'll put 5 squared to the x is equal to 1/5. And we also know that 1/5, like we just saw before, is equal to 5 to the -1. So instead of putting 1/5, we're going to put 5 to the -1. Okay? And we know that if you have a exponent to the exponent, you can multiply those two together. So this is actually 5 to the 2x. So actually 2x is equal to -1. So in this case, x is equal to -1/2. Okay? And then here we got 25 to the 1 minus x, which would be same as 5 squared to the 1 minus x is equal to, and if we put 125 under 1 in terms of 5, we would put 5 to the -3rd, because 125 is 5 to the 3rd. We invert it with negative exponent. Okay. So now we can multiply 2 times 1 minus x, and that's the exponent. It's equal to -3. So if we were going to solve for x here, that would be it would be 1 minus x equals -3/2, minus 1 from both sides, so -x equals -5/2. X is equal to 5/2. X is equal to 5/2 for that one. Okay, now this one here. Let's put both in terms of a base of 3. So 9 is 3 squared. And the left side we have, let's see, 3 to the -1 to the x plus 2. An exponent to an exponent, you can multiply those two together. So it's 3 to the -x minus 2 equals 3 squared. So -x minus 2 equals 2. And so we add 2 to both sides, and we get -x equals 4. So x is equal to -4 for that one. Let's see this one here. We're going to put both sides in terms of a base of 3. Let's see, 243. So this would be 243 is equal to like 81 times 3. So what power of 3 is that? Well, 81 is 3 to the 4th power, right? Because it's 9 times 9. And then times 1 more 3, so that would be 3 to the 5th. So the right side is 3 to the 5th. The left side is 3 to the -1 to the x plus 1. So that would be, we could multiply these two exponents together, so we get -x minus 1 equals 5. So we add 1 to both sides, and we get -x equals 6, and x is equal to -6. Right? Let's see this one. 2 to the x times 1 to the 8 to the 1 minus x equals 1/4. Let's put everything in terms of base 2. So this would be 2 to the x, and then here we have 2 cubed, because 8 is 2 cubed, to the 1 minus x equals, and this would be 2 to the -2, because it's 4 inverted. And so this would be, now when we have exponent of an exponent, we can multiply them together, so that would give us 2 to the 3 minus 3x. And then when we have two bases, we add the exponents together, so that would be 3 minus 3x plus x. So that would be 2 to the 3 minus 2x. equals 2 to the minus 2. And so that would be, let's see, 3 minus 2x equals negative 2. And then we add, subtract 3 from both sides, and we get negative 5 equals negative 2x. We divide both sides by negative 2, and we get 5 halves. X equals 5 halves. Okay, and that's that one. This one we, let's see, this would be base 3 and base 2, because 24 can be expressed as, 3 times 2 times 2 times 2. This also has 3's and 2's. So this is kind of a more complicated one. It's got 2 different bases. So I got 3 to the first and 2 to the x plus 1 equals, and this would be 3 times, and then it would be 2 to the third. So based on this, these 3's match up. That's fine. Now the x plus 1 here matches up with the 3, so it would be x plus 1 equals 3. X plus 1 equals 3. X plus 1 equals 3, and this is a 2 here. So subtract 1 from both sides, and we get x equals 2. Okay, and then this one here, we got 5 plus 1/2 to the x. We're going to express it as factors of 5 and 2. So this will be 5 times 2 to the negative 1 to the x is equal to 2 squared times 5. So the 5's match up. And then the 2 squared matches up with this. This is actually 2 to the, and we can multiply these together because it's an exponent to the exponent. 2 to the negative x is equal to 2 squared. So negative x is equal to 2. So x is equal to negative 2. Okay, now we'll do these last two. 9 to the x minus 12 times 3 to the x plus 27 equals 0. This is, something like, a squared plus 2ab plus b squared, something like that. We just want to factor it into two binomials. So this first one is going to be 3 to the x squared minus 12, 3 to the x, plus 27 equals 0. Let's see. So if we were going to make this into two binomials, the first term would be 3 to the x for both. Then to multiply together and get 27, it would probably be something like 3 and 9. And it's a plus 27, but the middle number is negative, so it would have to be a negative 3 and a negative 9. And that works out because if you multiply the inside ones, it's negative 3x, and the outside ones is negative 9 3x. If you add those together, you get negative 12 3x, and that's what we wanted. So that worked out. Now let's figure out when that's equal to 0. Well, that's equal to 0 when 3 of x minus 3 is equal to 0. Minus 3 is equal to 0. Or when 3 of x minus 9 is equal to 0. Okay, so when either of these two binomials is equal to 0, then the whole thing is equal to 0. Just like whenever we've done other factoring problems, if we add 9 to both sides here, we get 3 to the x equals 9, so x equals 2. If we add 3 to both sides here, we get 3 to the x equals 3, and so x is equal to 1. So the two solutions are x equals 1 or x equals 2. Last one here. 49 to the x plus 1 is equal to 2 times 7 to the x. And first thing we need to do is put everything on the left side. So we got 49 to the x minus 2 to the 7x plus 1 is equal to 0. And the next thing we need to do is we need to express the 49 to the x as a power 7. So we're going to put 7x squared minus 2 to the 7x plus 1 equals 0. And then we need to factor this. So we have 7x in both binomials. And then factors of 1 would be 1. And then both of them would be negative. And so this works out, right? Because the inner product would be negative 1 times 7x, and the outer product would also be negative 1 times 7 to the x, negative 2 to the 7x, okay? And so let's see, when is that equal to 0? When 7x minus 1 is equal to 0, you add 1 to both sides, 7 to x equals 1, so it's when x equals 0. Okay, so that's it for this section.